Good evening. All right, so we're looking at the topic of matrices. Now, when we speak of matrices, you're looking at different ways in which information is stored. For example, let's say you had some information that was tabulated, right? So it was given in the form of a table. So let's say they gave you fruit. Maybe you had apples and grapes. Right, so you're comparing grapes, prices of grapes and apples at different stores. Right, so maybe you have a fruit, you have store one, store two. Right, so it's just an example of matrices. So let's say this is the money that, right? So let's say this is the money that was by somebody comparing the prices of apples and grapes from two different stores. Now, in a matrix, you can take information which is represented in a table form and put it into the form of a matrix. So this data, you can pull it out without any commas, without any columns or rows. I mean, you're going to put it like in columns and rows, but you're not using rule to draw them. And we can represent it in a form of a matrix like this. You can use round brackets for matrices, and some books you might see it as square brackets, right? Whichever you choose, it's up to you. All right, so matrices, you can add, you can subtract, you could multiply matrices, right? So we can add, subtract, and multiply matrices. Now, when it comes to matrices, with respect to all right, sorry about that, guys. I think I got booted, right? But we can look at addition and subtraction of matrices. Now, you can add or subtract matrices if they are of the same size. Now, first things first, let's understand what they mean by the size of a matrix. Right, so matrices, I can tell the size of a matrix or the order of a matrix by counting the number of rows by the number of columns. Right, so we'll understand the size of the matrix first. All right, so I'm just recapping. So let's say they gave you a matrix like this. In order to know the size of the matrix, we put it in the form of the number of rows by the number of columns. Right, so you check the number of rows. I have 1, 2 rows. And you check the number of columns. So I have 1, 2 columns. So in this case, the size of this matrix will be a 2 by 2 matrix. Let's say they gave us one like that. And they asked you for the size or order of this matrix. You first check your number of rows. You have 1, 2 rows. And then you check your number of columns. I have 1, 2, 3 columns. So it's a 2 by 3 matrix. I have a question. Do we multiply this and get 2 times 3 is 6? No. If they ask you for the size of the matrix, this is all we have to do, right? This is all. If they gave us one like this, and they asked us what's the size of this matrix, you check your number of rows, 1, 2, 3, times or by your number of columns. I have 1 column. So this is a 3 by 1 matrix. Or if I gave you 1, 2, 3 like this and this, they are different, right? They are not the same size. This one is a 3 by 1. And let's see this one. This one is going to be 1 row by 1, 2, 3 columns. So this one is a 1 by 3 matrix. They are different. Right? So now we understand what is the size of a matrix. And if they ask us what is the size or the order of the matrix, we know this is what we write. They love to give us this in multiple choice to trick us. Right? It also comes in your paper 2 and your paper 3. All right, so let's see. Addition. Now, you can only add or subtract matrices which are of the same size. Right? So that's your first rule. Right? So we can only add or subtract matrices of the same size, meaning that I can add a matrix of this size, which is a 2 by 2 matrix, or subtract it to with respect to another 2 by 2 matrix. So I could add or subtract matrices of the same size, but I cannot subtract a matrix like this. Right? Because they are of 2 different orders or 2 different sizes. All right, so I'm just going to practice like 2 of them for time purposes, and then we move on. I'd like to complete the entire recap of this. today. All right, so let's say they gave us this to add. All right, so if they gave you something like this to add, they are of the same size. They're both 2 by 2 matrices, which means I could add them. You can only add or subtract corresponding element. So every number or letter in these brackets, we call it our elements or members, right? So we add or subtract corresponding elements. All right, so what does that mean? This corresponds with this. You can add or subtract depending on the operation given, those 2 digits. So 1 plus 5 is 6. Added like normal, subtracted like normal. These 2 numbers, they correspond. So I can add those 2. 7 plus 3, that's 10. These 2 are in corresponding positions. So I can add those 2. 6 plus 2, that's 8. And then these 2, they're in corresponding positions. So I can add those 2. 8 plus 4, 8, 9, 10, 11, 12. Right? So it's going to be this matrix. You have to apply your rules of integers as well. So we'll have 1, 3, 2, 4, minus 2, 6, 4, 8. All right, so corresponding elements, 1 minus 2. You have to apply your rules of indices here. So 1 minus 2, that's minus 1. 3 minus 6. 3 minus 6, we subtract the sign of the larger number, that's minus 3. 2 minus 4. 2 minus 4, I got negative 2. And 4 minus 8, that will be negative 4. Right, so that's our first rule, adding and subtracting matrices. All right, so our next step is multiplying by a scalar quantity. Now, this will be number 2. Right, so we'll have multiplication and we have 2 forms. 1, if we have a number outside, so this number here could be anything. It could be a decimal, it could be a fraction, it could be a letter, it could be a whole number. So if you have one number outside of the bracket, so let's say they gave you something like that. Now you have to understand anything outside of your brackets, it's telling me to multiply by what's in the bracket, right? And just like your distributive law, where you had to multiply whatever is outside by everything inside, you have to do the same for this. So you're going to multiply that 5 by each digit inside. So you're going to have 5 times 1, that's 5. 5 times 3, that's 15. 5 times 5, that's 25. 5 2s are 10. 5 4s are 20. And 6 5s are 30. So it could be fractions, it could be decimals, it could be whole numbers, it could be letters. Whatever is outside, we'll multiply by everything inside. Right, so we'll call this one scalar multiplication. Next, you have to know about equal matrices, where if matrices are equal to each other, let's say A, B, C, D is equal to 1, 2, 5, 6. Corresponding elements are equal. Right, so that means this will be equal to this. So A is 1. This will be equal to this. So B is 2. This is equal to this. So C equals 5. And this corresponds with this. So D is equal to 6. Next step, multiplication, matrix by a matrix. All right, so let's look at multiplication with respect to a matrix by a matrix. Right, so they want us to multiply one matrix by another matrix. Now, these are only possible if the two matrices are compatible. So let's say they give us a matrix like this. I'll do an actual, let me do an actual example. So let's say they gave us 1, 4, 3, 7, and they asked us to multiply it by 1, 2, 3, 4. Now, the first step is you have to find out if these matrices are compatible, right? So are they compatible? Now, what does compatible mean? First things first, you have to find out what are your sizes or your orders of each matrix. So this matrix is a 2 by 2 matrix. This matrix is also a 2 by 2 matrix. In order for them to be compatible, these two inner numbers, right, the two inner numbers, they must be the same for them to be compatible. Right, so these two must be the same. Once they are the same, you could multiply them. If they are not the same, you cannot multiply them. That's a rule. Right, so once they are the same, we can multiply them. If those two inner numbers are different, you'd simply let them know that they are not the same, hence they are not compatible and cannot be multiplied. You let them know clearly. Don't even waste your time to try to multiply it. All right, so let's say they gave us one like this. You checked and you made sure that they are compatible, so we can multiply them. Now, there's a rule. First, well, not really so much a rule, but I like this little sing song. First times the first plus the second times the second. First times the first plus the second times the second. First times the first plus the second times the second. I could write it here for you to see what I'm saying. It's the first times the first plus the second times the second. Of course, but math permits me to multiply first. Right? So first times the first plus the second times the second. Anytime I think of matrices and multiplying, that song just stuck in my brain. All right, so what does that mean? So they gave you a pair of matrices. We saw that they are compatible, that we can multiply that. In matrices, it's always row by column, row by column, row by column. If that makes it difficult for you to remember that it's always row by column, just think of RC. You know, RC Cola or RC as in Roman Catholic. You guys can just remember it, and it helps you to just remember that aspect of matrices. It's always row by column. It's always RC, right? So we're going to go each row, right? So each one of these rows, you have to multiply by each column, right? So it's always the first one will be the rows and the second one will be the column. So what we do is we go in first times the first plus the second times the second. So it's the first element times the first element plus the second element times the second element. Right, so I'm finished that row by that column. So I have to multiply this row now by this column. So you go in first times the first element times the first element plus the second times the second. Right, so it's just repeated, it's a pattern. Then I'm finished with that one. So I'm going to go to the next row and multiply it by the first column. Same thing, first times the first. It's always the one from the row first and then the one from the column, right? You're always going from left to right. Don't we read from left to right? Yeah. So you start from this one on the left and then the one on the right. Plus the second, which is the 7 times the second. Then do this part over. All right, so here's what I'll do. I'll complete this one and then I'll do another one as practice. So you're going each row by each column, right? So, all right, so I was asked to go over it. So just allow me to go over it. Just a second. All right, so let me just do it over. You're hearing me clearly, right? Okay, awesome. So they asked us to multiply this matrix by this matrix. You are going to multiply row by column. It's always row by column. The size was row by column. Multiplication is row by column, right? And it's each row by each column. So my first row, I'm going to multiply by my first column in the second matrix, right? So you're going to multiply first, the first element by the first element. So first times the first plus your second element times your second element. We always read from left to right. So you read the number in the row first and then the column. Right? So it's always left and then the right matrix. So I'm finished with those two. Now remember, it's each row by each column. So this row now, I want to multiply it now by this column. So it's going to be first times the first How do I know to write it up here as a question? It corresponds, right? So I'm working in the top row, which means my answer is going to be my top row. And I'm working with the one on the right column. So my answer will be in the right column. So it corresponds. So you're going first times the first plus the second times the second. It's a sing song. I'm finished with that row by each column. So I'm going to the next row and I'm going to multiply by each column in the next matrix. First times the first plus the second times the second. Second row times the second column, same thing. First times the first plus the second times the second. Now, here's a check. If you want to check and make sure that you were correct, you can check because look at your multiplication sign throughout. Watch this trick out. My first matrix was 1, 4, 3, 7. In front of each of your multiplication signs, you're going to see a replica of that first matrix. 1, 4, 3, 7. See? Same exact digits in this will be before your multiplication sign. Again, look at it here. 1, 4. Let me change the color. 1, 4, 3, 7. And then for the second digit, these will be the same. See? So the numbers after the multiplication sign, they're the same. So 1 and 1, 3 and 3, 2 and 2, 4 and 4. Right, so that's just like a check. Right, so you did it. You did it super speed, and you want to check back to see if you did it correct. We can do that little check. Then, BODMAS, we apply our BODMAS and we simplify. Right, so we're going to solve and reduce. So we'll have 1 times 1 is 1, plus 4 3s are 12. Remember, BODMAS tells me multiply first and then you add. So I'm going to work each of these individually. So 1 2 is 2, plus 4 4s are 16. Working here now, 3 1s are 3, plus 7 3s are 21. 3 2s are 6, plus 7 4s are 28. Then we simplify that further now because we can add each of the numbers in each element. Right? So you're not adding this to this, huh? You're just adding these in these separate sections. So we're going to add this, add this, add this, add this. It remains a 2 by 2 matrix. So we'll end up with 1 plus 12, that's 13. 16 plus 2, that's 18. 21 plus 3, that's 24. And 28 plus 6, 28, 29, 30, 31, 32, 33, 34. And that's our answer. I'll do another one. All right, so they gave us another one where they told us that matrix A is equal to 3, negative 2, 1, 0, 2, 2. And they gave us that B is equal to 0, 1, 3, 2, 2, 0. And they asked you to find A plus B. You cannot find A plus B, right? Right? And if they give you a question, I guess you let them know we cannot add a matrix like this. The reason why is because they have to be the same size. I mean, I know you guys might say, but mess is the same number of elements in it. But remember, when it came to the size, that's what we were working on earlier, right? So if they ask me for the size of this matrix, it's the number of rows by the number of columns. So you check your number of rows. 1, 2, 3, I have 3 rows and 2 columns. So this is a 3 by 2 matrix. This one, they gave us 2 rows and 3 columns. So this one is a 2 by 3 matrix, a 2 by 3 matrix. So they are not the same. Yeah, one is a 3 by 2, the other is a 2 by 3. So let's say they ask you to find AB. AB means A times B. So matrix A multiplied by matrix B. So you check the size of each matrix. Once your 2 inner values are the same, you can multiply. So once they're the same, you could multiply it. If they're not the same, you cannot multiply it, and you simply tell them straight, these 2 matrices are not compatible, and hence they cannot be multiplied. If you don't and you try to be a superhero and you work out something that cannot be multiplied, it just shows that you do not understand, and you'll lose points. You'll lose your marks. Right? So these 2 are compatible, so we could multiply them. Remember, it's always RC, right? So it's always row by column. So I have to multiply each row by each column, right? So it's going to be each row by each column. All right, so we're multiplying matrices. Good evening. Right, so we're multiplying matrices. So far, you can only multiply matrices if they are compatible. Compatible means when I line up the size of each of these matrices, your inner numbers will be the same. Right? Or in other words, the number of elements in the rows of your first matrix will be the same as the number of elements in the column of the second matrix. Then remember our little sing-song. First times the first plus the second times the second. If it happens that you have 3 elements in it, then you're going to go first times the first plus the second times the second plus the third times the third. Right, so if there are 3 elements within the row or within the column, then you just add on the third plus third times the third. So we're going first element in your first row times the first element in your column in your second matrix. So first times the first plus the second times the second. So the second element times the second element. Then I'm finished with that row and that column. So I'm going to continue this row now by the second column. Now it corresponds. So I'm in the top row, but second column. So that means I'm going to write it here. Same thing. First times the first. I leave a space. Plus the second times the second. Finish with that one. So I'm going First row, third column, because it's each row by each column. So take any first row, do it to each column. Second row, do it to each column. Third row, do it to each column. Same thing. First times the first. Plus the second times the second. Could I just make some space so that we could see it fully? Oops, no. All right, so I'm just redoing this part so that we can see it fully. Now, when you're doing this part on your exam, give yourself some space, huh? Give yourself space. Right, so I'm just repeating. Right, and then first times the first plus the second times the second. Next one, I'm finished that row by each column. So first, the second row, first column. First times the first plus second times the second. Second column, first times the first plus the second times the second. Next, first times the first plus the second times the second. Finish with that second row by each column. So I'm going to go last row by each column. So last row, this one, first times the first plus second times the second. And this one by your second row, first times the first plus the second times the second. And then last one, last row by your last column. First times the first plus your second times the second. Now, take your time and do it the first time, because this one is easy. This one is easy to get your full marks with, right? It's just, it takes a little time, but if you're spending your time with it, give it your all the first time, so you don't have to repeat it. Now, if you want to check to see if it's correct, before each multiplication sign, you're going to see a repeat of your first matrix. So look at it. This is 3, negative 2, 1, 0, 2, 2. 3, negative 2, 1, 0, 2, 2. So before each multiplication sign, you're going to see these elements repeated for your first matrix. If there's a shorter way, you find this way too tedious. Now, you find it long. Now, some people, what they can do is, you see this observation that I'm pulling out here. You could look into that. You could look into doing it in that way, where before each multiplication sign, you are going to see a repeat of your first matrix. All right, so look at it, 3, -2, 1, 0, 2, 2. So each column, you're going to see it before each multiplication sign. So 3, -2, 1, 0, 2, 2. 3, -2, 1, 0, 2, 2. And then after each of your multiplication signs, you're going to see 0, 2, 1, 2. So if you look at it, 0, 2 for the first column, 1, 2 for the second column, 3, 0 for your third column. And then you just simplify each. Right, so 3 zeros are 0 plus -2 times 2, that will be -4, 2 2s are 4. 1 0 is 0, plus 0 2s are 0, 2 zeros are 0, plus 2 2s are 4. 3 1s are 3, plus -2 times 2, that's -4. 1 1 is 1, plus 0 2s are 0, 2 1s are 2, plus 2 2s are 4. 3 3s are 9, plus 2 times 0, that's 0. 1 3 is 3, plus 0. 2 3s are 6, plus 0. So we simplify it. We multiply each subsection, and then we add. So 0 plus -4, that becomes 0 minus 4, which is -4. 0 plus 0 is 0, 0 plus 4 is 4. 3 plus -4, that becomes 3 minus 4, which is -1. 1 plus 0 is 1. 4 plus 2 is 6. 9 plus 0, that's 9. 3 plus 0, it's 3. And then 6 plus 0, that's 6. It says, explain why the matrix product QS is not possible. Now, QS actually means Q multiplied by S. Now, we already know that not all matrices can be multiplied, right? Some matrices, because of compatibility, it may not be able to be multiplied, right? So we know what's the test to see if they're compatible, right? And it all boils down to the size of each matrix. Now Q is equal to 2 -1 4 3. Now Q is a 2 by 2 matrix, right? So remember, it's always row by column. So you check your number of rows, 1, 2, and times your, or by your number of columns, 1, 2. You do not multiply it. So if they ask you for the size or the order of that matrix, it's just a 2 by 2. That's the answer. And then S, it was 2, 7, 4, -1, -8, 9. So this one, the number of rows would have been 1, 2, 3 rows. By the number of columns, we have 1, 2 columns. So this one is a 3 by 2 matrix. Now, anytime your inner values are not the same, they are not compatible. So these are not the same. So cannot be multiplied. All right, so not the same, so cannot be multiplied. And that basically explains it. And I'll show you why. Look at Q. Right, remember it's always each row by each column. In this row, we have 2 elements, but in the column, we have 3 elements. So it can only work out if you have the same number of elements in the rows in the first matrix as compared to the columns in the second matrix. So that's our reasoning there. All right, so let's look at our next question. All right, so the second one, they said, state the order. Remember, order is the same as size, right? So basically, they want the size or the order of the product of SR, right? So when you multiply S times R, they want to know what is the matrix size or the order. Now for this one, remember, whatever is first, that's what you're going to multiply first. Because remember, before in multiplication, if you have 7, like 6 times 2, it was the same as 2 times 6. But in a case like this with matrices, if I multiply S times R, it may not be the same as R times S. Right, so they wanted SR. So S is first, Now they never asked us to solve it, huh? They just asked you for the size. Right, so S times R. Now I'm just gonna show you why or how I got this answer, right? First things first, you check to make sure that it's compatible. So this here is a three rows by 2 columns. And this one is a 2 by 2. The two inner elements are the same, so it's possible to multiply. Now what they want to know is what is the size of the matrix without solving it. Now, do you remember before when we did it? We did each row by each column. When we worked it out, we would have gotten an element. So like when you work this times this, you would have gotten one set of answers here. Right, so I'm just reasoning with you guys. And then when I multiplied this by this column, I got another set of elements here. Then when I multiplied this row by this one, I got one set of elements here. Right, so remember, we would have simplified it to get one here. Then this one by this one, I got another set of elements here. Then this by this, we got another set here. And then this by this. So we got another set of answers here. So your answer would have had one element here, another one 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 here. Right, so you can think of these as numbers. So you would have had 1, 2, 3 rows by 1, 2 columns. So your answer would have been a 3 by 2 matrix. Right, so your answer, they never asked us to solve it. All they did was start to state the order. So it was a 3 by 2. All right, so let's look at the last one now. Oh, not the last one. Let me just see the rest of this question. Nice. So they gave us these. All right, so the next one, they asked us to calculate the product of QR, which means they actually want us to multiply it. Right, so they want us to find QR. Right, so Q will be 2, 4, right? So this is Q here. So 2, 4, negative 1, 3. R would be 1, 6, negative 5, 4. So we want to multiply these two. Again, remember each row by each column. I'll work it with you guys. So I go in first row, first column. You know it's, you check your compatibility. The two inner are the same, so you can work it. Remember your pattern. First times the first plus the second times the second. You want a lot of space for this part. So you're going first times the first plus the second times the second. First, then I'm finished with that row by that column. So I'm going first row by second column. First times the first plus the second times the second. Next, we have the second row, first column. First times the first plus the second times the second. And then last row, last column. First times the first plus the second times the second. Now this is where we have our check, right? We have a little checkpoint because once we do it accurately, you know the digits in front of your multiplication sign is going to be a repeat of your first matrix. So it'll be 2, -1, 2, -1, 4, 3. 2, -1, 4, 3. And then your numbers after your multiplication signs, they correspond, they are the same. So 1, 1, -5, -5, 6, 6, 4, 4. Right, so you do that little check, and then you're going to work by simplifying. So we'll end up with 2 ones are 2 plus -5 by -1. It's two same signs, so we multiply, and it's going to be positive. 5 ones are 5. Going down to this one, 4 ones are 4 plus 3 times -5, that will be -15. Then 2 6s are 6 twos are 12 plus -1 times 4, that will be -4. 6 fours are 24 plus 4 threes are 12. Then you reduce it further. 5 plus 2, that's 7. 12 plus -4. Two different signs coming together, so it's reduced to a minus. 12 minus 4, that's 8. Minus plus becomes a minus, so this becomes -11. 24 plus 12, that becomes 36. All right, so we go through, you could double check. And we make sure that we get our solution. All right, so for this one, they asked us to determine this, right? And they gave us that matrix A is equal to this one. Now, first things first, we need to know what does this mean. Now, in matrices, if they give us this, this is the determinant of matrix A. Now, notice they didn't even mention the word determinant, right? So it's like they expected that you knew what this symbol means, which means we have to learn this. Now, the determinant of a matrix so let's say they gave us a matrix A and they told us it was A, B, C, D. If they ask you to find the determinant of A, which is this, or we could write it like this, right? So determinant of A we use the formula AD minus BC, right? So if you're given a matrix, you could label A, B, C, D above. It doesn't matter. Some textbooks, they might have it, right? So some textbooks, they might have it like this, where they have A, B here, and then C and D here, but it doesn't matter, right? So you label A, B, C, D. The reason why it doesn't matter is because what we're multiplying these two minus the product of these two. So if I have B here and C here, same thing. Now you have to know this formula. All right. Next, let's see how are we going to extract this information from A. So they gave us here that A is equal to 4 minus 1 minus 7x. I can label my elements as A, B, C, D, and I could substitute it into this formula. Now, you guys know I always share ways in which I remember stuff, right? In order for me to remember, I always have to link something to something in order to keep it in my memory. And how I used to remember this is AD, you know, in history, you have AD after that and BC before Christ. That's how I used to remember this. I used to remember it as after that minus before Christ. That's how I used to remember the two, so that I don't mix up the letters. Then I'll label each of my elements A, B, C, D. So I'll have AD, that's 4 times x, which is 4x, minus BC, so that's going to be minus 7 times minus 1. And I'll end up with 4x minus 7 times -1, multiply like normal, right? So it's going to become +7. Use brackets if it confuses you, right? Remember, when I multiply these two, it becomes positive. So this becomes 4x minus 7. And then they told me, now this here is my modulus of A. And they told me that my modulus of A is equal to 5. So that means this is equal to this. So they said find x when my, not modulus, sorry, I keep saying modulus, but it's determinant. This is known as modulus in another topic in mathematics, right? But in matrices, we know it as the determinant. So they said that the determinant is equal to this, and the determinant is equal to this. So that means this is equal to 5. By means of solving algebra, I can solve for x. So I'll carry this across, it becomes adding. So we'll have 4x is equal to 5 plus 7. 4x is equal to 7 plus 5, which is 12. X is equal to 12 over 4, which is 3. X is 3. And that's it. Now, what we'll do in our next session, which will be on Friday, please God, we're going to look at, we'll look at singular matrices and simultaneous equations with respect to matrices. All right, so we'll continue with this topic next class.